How would we know if we're living in a simulation? And what does that have to do with having a dream that you're a butterfly, or John Lennon, or Renee Descartes, or freezing yourself in a vat of liquid nitrogen? And how will we solve the problem that human bodies can't do space travel? Welcome to Inner Cosmos with me, David Eagleman. I'm a neuroscientist and an author at Stanford University, and I've spent my career studying the intersection between how the brain works and how we experience life. And what I'm going to talk about today is the possibility of living forever. What does that have to do with the brain? Would we want to live forever? And how could we get there? Humans have been obsessed with the idea of immortality for ages. As far back as documented history goes, there are stories of humans trying everything to unlock the secret to eternal life. In Arthurian literature, the Holy Grail was said to have miraculous healing powers, and it would grant to anyone who drank from it eternal youthfulness. And the ancient Egyptians, they would painstakingly prepare the physical body for the journey to the afterlife, and they believed you were reborn again and again. And China's first emperor launched an obsessive search for the elixir of life, and that obsession continues in cultures all over the world today. While leaving a legacy is the only thing close to immortality by today's standards, Woody Allen wanted the real thing. He said, I don't want to achieve immortality through my work. I want to achieve immortality through not dying. He said, I don't want to live on in the hearts of my countrymen. I want to live on in my apartment. So, what are our options for achieving eternal life? Well, the first option has to do with medical innovation, such that we keep repairing things that go wrong with the body. And in fact, it's rumored that life insurance companies assume in their actuarial tables that children born now are going to live to 114 years old. And this is based just on extrapolating medical innovation curves. In other words, you take the pace of medical progress and you guess what things are going to look like in a century from now. But the fact is, there are barriers to physical immortality, like aging and disease. And then, of course, there are accidents that can happen, like you fall off a cliff, or you get in a car accident, or a tornado gets you, or a volcano explodes, and on and on. So although we can continue to make improvements in medical science to expand the average lifespan, there's no real guarantee that your lifespan is going to be any better. Now, there's a second approach that some people have taken, and that's about making a throw to the future when people will know things like how to repair bodies. The issue is that we just don't know how to cure lots of problems now, but it's not impossible that 200 years from now, a lot of this stuff will be obvious. In 200 years, we'll look back at our textbooks and we'll think, my gosh, how did we not know that? How did we not know that we can just reach in and tweak some things on the telomeres and cure cancer easily with a few zaps and essentially make ourselves live much longer, maybe forever? The problem is that this is in the future and not right now, and therefore we don't get any of the benefits of that. So the idea is perhaps you could, by pausing yourself now and rebooting yourself in that future. And that's the approach of a company called Alcor. Alcor is based in Arizona, and they have these giant silver tanks called dewars that are filled with liquid nitrogen, and they're kept at a temperature of negative 196 degrees Celsius. So when you're expiring on your hospital bed, this company gets contacted either by your family or because you're wearing a special bracelet. And as soon as your heart stops, a team from Alcor rushes to your bedside and starts the deep freezing process. Then they transport your body to Arizona, where they put it in the giant vat with the liquid nitrogen. And you actually have two choices here. You can freeze your entire body, Or if you can't afford that, you can just have your head removed and just have your head frozen. Because while it's great to have your whole body, the real representation of who you are is theoretically just kept in the brain. Or suffice it to say, that's the densest representation of who you are. You just need the head. Now, as a side note, you might wonder how much this costs. Well, you don't actually have to pay anything up front. Instead, you can modify your life insurance payment to make its payout to the company. So this allows you the possibility of living a second chapter. Now, if you're unfamiliar with this slice of the world, it will blow your mind. I visited Alcor and met the then CEO, Max Moore, for my television show, The Brain, and I got to tour around the facility, and it's quite striking. There are these, giant silver vats of liquid nitrogen, and they currently have 208 people stored in there. And the company has over 1,400 people who are signed up for the service, but they haven't died yet, and they will eventually end up in these vats. Now, although scientists don't currently know how to unfreeze and revivify a body, the idea is that some generation in the future will figure that out. Maybe that's a century from now, or maybe that's a millennium. And then the idea is that the frozen person will awaken into a new world. So people who sign up for this service operate on hope. They're making a deep football throw into the future, hoping someone will be there to catch it. And some people choose to cryopreserve their pets also. The idea is that if you awaken to a completely new reality, that's likely to be disorienting. And if you have a familiar fuzzy face by your side, that could be really nice and reassuring. Also, it turns out that Alcor allows you to have a small memory box to go along with your frozen body. And the reason I mention this is because sometimes people ask me to inscribe one of my books to them, but I recently got a really interesting request from a man who had just signed up for Alcor. He said he'd been moved by my book, The Brain, and wanted to keep that in his memory box that goes along with the frozen body. So he'd have it in his new world when he gets rebooted. So he asked me to sign my book for his revivification in a century or two. In other words, I would sign the book to him for his re-entry into the world sometime in the future. Now, I've had a lot of cool requests to sign books for special occasions, but signing for someone who is possibly coming back in a couple of centuries, that was a new one for me. So here's what I wrote. Dear Steve, welcome back. I'm so curious what secrets the world has divulged now. Presumably, the textbooks have been thoroughly rewritten, and the current understanding of science would intimidate and thrill a 21st century mind. Presumably, I am long gone, and all that remains of me are fading echoes of my genetic code. But this book remains. It memorializes what we knew in the early part of the millennium. Like all snapshots of science, some notions will stale, while others will prove more durable. Whatever the case, these pages form a bridge. They allow me to talk with you as though we still live contemporaneously. They allow two brains to span an unknowably wide chasm of time. Enjoy the future, David. So, that's the method of freezing yourself until biology is better understood. It's a Hail Mary throw, and you don't know for sure that anyone's going to catch the ball. For all you know, society will have collapsed, and maybe your body is going to get cannibalized. Or legislatively, something might happen in the future where all these frozen bodies don't get unfrozen. Or we are long blown up in a nuclear war, and there's nobody there to unfreeze you. But people who sign up for this figure that at least they have a non-zero chance of something happening here, of getting to live a second chapter. And that's better than having 100% certainty that you're going to die. But fundamentally, there's a problem that's probably intractable, which is that we are made of biological pieces and parts, and those things are going to wear down. Even if we're able to successfully unfreeze people, the ticking clock of aging will keep ticking, And we're always going to be racing against entropy. As the poet William Butler Yeats said, things fall apart, the center cannot hold. And this is what aging and death is. And that brings us to a question of how we might solve this for the long term, forever, by just extracting the part of us that matters, our consciousness. So, could it be possible someday to upload our consciousness out of our brains and onto a different substrate like silicon and run it? And would that still be you? So here's the idea. Maybe the hardware of the brain, all these cells, that's not the important part, but instead it's the software of the brain that matters. In other words, the algorithms that are running. Maybe that's what makes a mind. Maybe it's the patterns by which these spikes, these zeros and ones are running. And if we could extract those massive patterns and reproduce them on something different, maybe that would be you. This idea is called computational equivalence. The idea is that the 86 billion cells of the brain are just running algorithms that have been sussed out by Mother Nature over billions of years. But fundamentally, it's just code that's being run. And so the idea of computational equivalence is that it doesn't matter if you reproduce this system out of Legos or Tinker Toys or ball bearings or silicon. If the system runs the same program, you will get the same consciousness. You will get you. Now, we don't know if the theory of computational equivalence is correct, but if it is, it implies that we could shift ourselves off the degrading biological substrate of our bodies, and with powerful enough computers simulating all these neural interactions, we could upload our consciousness and exist digitally, circumventing the inevitability of demise. That would be the single biggest leap in the history of our species, launching us into an era of transhumanism. Just imagine what it could look like to leave your body behind and wake up in a simulated world. Your simulated existence could look like anything you wanted. Programmers could make any virtual world for you. If you've ever wanted to fly or breathe underwater or inhabit an alien planet, you just sign a contract for it and you pay, and that becomes your new existence. It's your simulation and your reality is up to you. And as a side note, we could, in theory, run virtual brains as fast or slow as we wanted. So in seconds of computing time, you could have thousands of years of experience. In fact, even if the cosmos were coming to an end tomorrow, the programmers could simulate 1 billion more years for you in that time. So all that sounds great, but there are some technical and theoretical hurdles. The first one is the enormous difficulty of figuring out the secrets of the brain. And this is a problem that can't be underestimated. As much as we've discovered about how the brain works, we are a long way off from understanding the big picture. It's a very tough problem. You've heard me mention before on this podcast that the brain is the most complex device we have ever discovered. It has almost 100 billion neurons. Each of those is as complicated as the city of New York, and you've got detailed connections between them that number in the hundreds of trillions. So figuring out the algorithms running in the system, or even just scratching the surface of those, is something that still, for the most part, has completely eluded us. Consider this experiment that a couple of my colleagues did in 2017. They asked, what would happen if we used our best neuroscience approaches to understand a simple microprocessor, just a computer chip? So if the brain is really like a giant complex computer chip, let's see how far we can get by analyzing this very simple one. So they picked an Atari microprocessor from 1981 that ran Donkey Kong. And it turns out that after measuring all the input and output signals from the chip and applying the type of analyses that we have in neuroscience, they couldn't say much of anything about the function of the chip. I mean, note that they already knew what the chip accomplished and they know how chips work. But when you're looking at a ton of zeros and ones streaming in and streaming out, it's really difficult to say, okay, here's the algorithms that the chip is implementing. As the researchers put it in that paper, quote, in the case of the processor, we know its function and structure, and our results stayed well short of what we would call a satisfying understanding. So figuring out what the brain is implementing may turn out to be really hard, but we might be able to copy the structure of the brain long before we actually understand it. So if I simply run the instructions to three-dimensionally print a microprocessor, I don't have to understand how it works. I just have to understand how to run the printer, and the chip will come out and will magically do all the things that the original one did. So can we copy the brain? Well, we're nowhere close to copying the human brain because the detailed structure of it is so enormous. It's probably a zettabyte of data, which is maybe around a tenth of the computational capacity of our planet right now. But this is fundamentally just a technology challenge. And the way that things are going, we will probably get there at some point. It may not happen in our lifetime, but it's essentially guaranteed to happen in the future as our computational power increases. Okay, but this brings us to a tougher hurdle, which might be a theoretical one, which is there may be physics happening in the brain that don't make it as easy as copy-pasting a giant document. For example, the brain might be exploiting quantum mechanical effects. And if so, that means we can't pretend the brain is just a big clockwork machine. Quantum mechanics is the science of the very small. It explains the behavior of subatomic particles and how they interact with each other and with light. The thing is that it's extraordinarily counterintuitive, and it's not really anything like classical physics. And we have no idea how to build a quantum system the size of the brain. Now, I'll just mention there are many scientists like Roger Penrose, who recently won the Nobel Prize, who suggest that there might be quantum mechanical effects in the brain. And there are many more scientists on the other side of the debate who say they think there aren't quantum mechanics in the brain. But I just want to note that we don't actually know. Some people make fun of the quantum mechanics approach and they say something like, well, quantum mechanics is mysterious and the brain is mysterious, so maybe they're the same thing, ha ha. Okay, skepticism is always warranted until something is demonstrated to be true, but science doesn't rule things in or out in advance of having enough data. So when it comes to quantum mechanics, we don't actually know yet. Part of the problem that people have accepting quantum mechanics is that it's poorly understood and it's relatively new for us humans. But remember that for Mother Nature, quantum mechanics has been around from the beginning. And one thing that's clear is that if there's something Mother Nature can take advantage of, she will. So maybe quantum mechanics has nothing at all to do with the brain or everything to do with the brain, but we can't rule it out yet. And if it turns out that the brain is not so straightforward, but requires quantum effects or whatever we discover next century, like super hyper quantum X effects, then this path of learning how to reproduce the brain might take much longer. Maybe we'll need quantum computers or something we haven't even thought of yet. And I want to mention a third technical hurdle to successfully uploading our consciousness, which is that the simulated brain has to be able to modify its own structure. This is what's known as brain plasticity, and some of my other episodes have been about this. The activity that runs through a brain modifies the brain. It changes the brain. That's why you have memory, for example, because everything you experience is actually changing the physical structure of your brain so that activity runs through it differently next time. When you learn that the name of this podcast is Inner Cosmos, that physically changes the structure of your brain so that when someone asks you, hey, what was the name of that podcast? Your brain can retrieve that information. So we need to simulate not only the detailed structure of the brain to run the software, but we also need to understand the physics of the ongoing interactions and how it changes. For example, in the brain, you have the activity of transcription factors that travel to the nucleus and change gene expression. You have dynamic changes in the location and strength of the synapses, the connections between neurons, and so on. And unless your simulated experiences change the structure of your simulated brain, you couldn't form new memories. You'd have no sense of the passage of time. Your consciousness would be frozen at whatever point it was uploaded into the simulation. Under those circumstances, would there be any point to immortality? Okay, so let's imagine that 200 years go by and we manage to surmount all those technical hurdles. We have enough storage capacity, we figure out any quantum effects, we make it so that the simulation self-modifies based on its experience. So great, we're there. And in this future world, uploading our consciousness would be possible. Now, what would that mean for the human species? Well, among other things, it would open up the possibility of getting to other solar systems. There are at least 100 billion other galaxies in our cosmos, each of which contain 100 billion stars. We've already spotted thousands of exoplanets orbiting those stars. They're planets that are like Earth in some way. And some of those have conditions quite like the Earth. But the impossibility lies in the fact that our current fleshy bodies will ever get to those exoplanets, because there's just no real way that we're going to be able to travel those kind of distances in space and in time. But uploading would allow us to transfer our minds into bodies that are built for space travel. And that way we could travel between stars and between galaxies with a human mind and a titanium body. Also, note that with a simulated mind, you could pause the simulation. You could shoot it out into space and reboot it 1,000 years later when it arrives at a planet. So it would seem to your consciousness that you were on Earth, you had a launch, and then you instantly found yourself on a new planet. In other words, if you could upload your brain into silicon, this would be equivalent to the physics dream of finding a wormhole that lets you get from one part of the universe to another in a subjective instant. Okay, so we've established that if the algorithms are the important part of what makes you who you are, rather than the biological, physical stuff, then it's a possibility we'll someday be able to copy our brains and upload them onto silica and run them there. But there's an important question here. Is it really you? I was thinking about this the other day because Paul McCartney announced an upcoming song with vocals by John Lennon, thanks to AI that brings Lennon's voice back to life. But even though John Lennon is out there singing new songs now and everyone's talking about his immortality, he doesn't get to enjoy it. John Lennon doesn't know that he's been brought back. It's just zeros and ones running on a computer. John Lennon doesn't get anything out of that. So even if there's a super complete simulation of you, is it really you, or is it just zeros and ones? Well, I think this could be argued either way. For example, every night when you go to sleep, it's like you are turning off. And then the consciousness that awakens on your pillow in the morning inherits all of your memories. And we say, yeah, I'm the same person who climbed into this bed last night. I turned off and then I turned on again, and it's me, and I'm getting back to business. So maybe the process of transferring from your physical body to a computer is just like that, where you open your eyes in the simulated world and you think, cool, here I am, let's get back to business. But there's another way to look at this too, which is that possibly when some company scans your brain and then uploads you into the computer, that's not you at all. That's just a computer program that's running. And that program happens to feel confident that it's you. It has all your memories and beliefs and thinks that it was just there standing outside the computer in your body. But its existence inside the computer doesn't help you at all. Let's imagine you just paid $1 million to this immortality company and they tell you, hey, it worked. You see this little coordinate moving around on the screen? That's you. You're living forever now. And then you leave the immortality company and you drive home and sit on the couch and your life is no different. You are still heading towards death. It's just that you've paid all this money so that some computer simulation has a good afterlife. But is that really you? Did you gain anything out of paying this $1 million? The actual situation is that there are now two of you. It's not like your consciousness is split or something, because you immediately move off on different trajectories with each new experience. Your brain and the computer simulation's brain are becoming different. So it really is like two separate beings. Now, interestingly, there's a philosophical question here about the timing. If the company uploads a copy of your brain to the computer and you go home, then it definitely seems like you have not achieved immortality. But if the company kills you and turns on the computer 1 second later, then it's like a transfer. You've gone from being inside your body to being inside the virtual world. It's like waking up on your pillow. Now, you may well say, yeah, but I'm not actually sure that's me inside the virtual world. It's like a recreation of me, but I'm dead. I just got killed by the company. But again, this is the situation when we turn off at nighttime and wake up again in the morning. And you can ask the same question about Captain Kirk beaming himself up in Star Trek. One moment he's standing on the surface of the planet, and then he gets completely disintegrated, and then he gets reconstituted inside the ship. But is that really him now inside the ship? Or was he actually killed on the surface of the planet, torn apart into his constituent atoms? And some identical version of his structure gets rebuilt, but it's a new creature. It's not really him. These are all thorny questions that philosophers and neuroscientists wrestle with. And there are versions of these questions, like, does it matter if you capture just the structure of the atoms that make up Captain Kirk and reproduce that structure with new atoms in the spaceship? Or whether you take his actual atoms and push those through space and rebuild him from his original atoms? Does it make any difference? Did he die in either case and it's just a rebuild of him? And by the way, returning to this question of timing, if the company kills you 1 second before turning on your simulation, they can call that a transfer. But if they kill you 1 second after turning on your simulation, then it's murder, because you have an independent existence from that computer program and they have just taken that away from you. So the timing matters. And what you can see is that these are all tough philosophical problems. Now, we've been conjecturing over whether you could reproduce consciousness, but it's of course a possibility that all of this conjecture is not conjecture at all. Maybe we have had these conversations 1,000 years ago and already figured out the key to successfully transfer our consciousness into a simulation. And the idea is that our reality is actually already a simulation. Now, thinking about these issues, this is not a new idea. 2,300 years ago, the Chinese philosopher Chuang Tzu wrote that he once, quote, dreamt I was a butterfly, fluttering hither and thither, to all intents and purposes, a butterfly. I was conscious only of following my fancies as a butterfly, and was unconscious of my individuality as a man. Suddenly, I awoke, and there I lay, myself again. Now I do not know whether I was then a man dreaming I was a butterfly, or whether I am now a butterfly dreaming that I am a man. And what this illustrates is the difficulty of knowing precisely what reality we're in. The French philosopher Renee Descartes wrestled with a different version of the same problem. He wondered, how could we ever know if what we experience is the real reality? So he proposed a thought experiment. He asked, how do I know that I'm not a brain in a vat. Maybe some scientists are stimulating that brain in just the right way to make me believe that I'm here and that I'm eating this delicious food and seeing these stunning colors and I'm listening to this podcast. And Descartes concluded there might not be any way to know. But he also realized something else. There's some me at the center trying to figure all this out. So whether or not I'm a brain in a simulation, I'm pondering the problem. I'm thinking about this, and therefore there is some I that exists. Je pense donc je suis. I think, therefore I am, irrespective of whether I understand precisely what that I is. Now, the modern version of the brain in a vat question is, how do I know if I'm living in a computer simulation? And in fact, some philosophers like Nick Bostrom have suggested that in fact, it is more likely that we are in a simulation than not. His argument is that once it becomes possible to create a computer simulation of reality, then it's likely that many such simulations would be created. And in this scenario, it is more probable that we are living in one of these simulations rather than the real reality. And in fact, there are several philosophical arguments that have been put forward to support this idea. One argument is that the universe appears to be exquisitely finely tuned for life, with the laws of physics being very specific, which suggest they might have been designed by an intelligent being. And while some people use this as an argument for religious creationism, some philosophers use this argument that we are perhaps the creation of a very convincing virtual reality, of a simulation. The question of whether we are living in a simulation seems impossible, at least at the moment, to know how to address scientifically. But it certainly seems like a possibility. I mean, we already know how easily we can get fooled into accepting our reality. Every night we fall asleep and we have these bizarre dreams. And while we're there, we believe in those worlds entirely. And then we wake up and we think, oh, that wasn't actually the real world. Now I'm in the real world. So we know that we are completely capable of being in simulations and believing them entirely. In other words, the mere existence of dreams may be sufficient evidence that it is possible we are living in a simulation. Now, if we are living in a simulation, could we escape from it like they do in the Matrix? Or are we trapped in it? Would we have any power to change the simulation? What's the purpose of the simulation? Who exactly created the simulation? Okay, so those are tough questions, and we really have no way of tackling them. But I want to pile on one more. I think there's an open question for us about the usefulness of immortality. Would you actually want to live forever? And let's say with your uploaded brain on a new substrate, you don't even require sleep. So for 400 years, you're looking for ways to occupy yourself. Time can be painful. Imagine for hundreds of years, you're looking for entertainment, like the best new series on whatever the streamers are at that point, or you're scrolling through your social media with infinite scroll, and it really is close to infinite. Maybe you actually reach the end of the internet. Is there a time when you say, okay, it's been 470 years. I am ready to wrap this up now. So I'll give you a sense of this from a short story that I wrote in my book, Some. So in this story, you become a famous medical visionary. And here's how it goes. You argue that there's no such thing as a natural death, and you raise millions to fund your research. You program computers to calculate all possible mutations of viruses before they happen, and you design prophylactic treatments against them. You compute the exact effects of every medication on the normal cycles of the body. Your aggressive anti-death program is a success. After the final breath of an incurably ill elderly woman, you are able to announce that hers represented the last natural death. Great celebrations ensue. People begin to live forever, healing just as they would when they were young, free at last from the overhanging cloud of mortality. You are greatly admired. But eventually, your success begins to lose its shine. People come to discover that the end of death is the end of motivation. Too much life, it turns out, is the opiate of the masses. There's a noticeable decline in accomplishment. People take more naps. There's no great rush. In an attempt to salvage their once dynamic lives, people begin to set suicide dates for themselves. It is a welcome echo of the old days of finite lifespans, but superior because of the opportunity to say goodbye and complete your estate planning. That works well for a while, rekindling the incentive to live strongly. But eventually, people begin to take the system with less than the appropriate seriousness. And if some large new development occurs, such as a new relationship, they simply postpone the suicide date. Whole cadres of procrastinators grow. When they reschedule a new date, others ridicule them by calling it a death threat. There develops enormous social pressure to follow through with the suicides. At long last, after many abuses of the system, it is legislated that there's no changing a preset death date. But eventually, it comes to be appreciated that not just the finitude of life, but also the surprise timing of death is critical to motivation. So people begin to set ranges for their death dates. In this new framework, their friends throw surprise parties for them, like birthday parties, except they jump out from behind the couch and kill them. Since you never know when your friends are going to schedule your party, it reinstills the carpe diem attitude of former years. Unfortunately, people begin to abuse the surprise party system to extinguish their enemies under the protection of necro-legislation. In the end, great masses of rioters break into your medical complex, kick the plugs out of the computers, and once again have a great celebration to mark the end of the last unnatural life. So although there's been a millennia-long reach for immortality, I think it's worth exploring this question of would it be worth it? So let's wrap this up for today. In the coming years, we are going to discover more about the human brain than we can describe with our current theories and frameworks. And at the moment, we are surrounded with mysteries, many that we recognize and many we haven't even yet registered. As a field, we have vast uncharted waters ahead of us. As always in science, the important thing is to run the experiments and assess the results. Some of the approaches are going to be blind alleys, and others are going to move us farther down the road of understanding the blueprints of our own minds and consciousness. But one thing is certain, which is that our species is just at the beginning of something, and we don't fully know what it is and where it's going. We are at an unprecedented moment in history, one in which brain science and technology are co-evolving. And what happens at this intersection is poised to change who we are and how we think about life and immortality. For thousands of generations, humans have lived the same life cycle over and over. We're born, we control a fragile body, we enjoy a small strip of sensory reality, and then we die. And science might give us the tools to transcend that evolutionary story because we can now hack our own hardware. And as a result, our brains don't need to remain as we have inherited them. If we are able to upload our consciousness, eventually we're going to be able to shed our physical forms altogether. So our species is just now discovering the tools to shape our own destiny, and who we become is yet to be imagined. To find out more and to share your thoughts, head over to eagleman.com/podcasts and send me an email at podcast@eagleman.com with questions or discussions, and I'll be making an episode soon in which I address those. Until next time, I'm David Eagleman, and this is Inner Cosmos.